All right, today we're going to continue with surface area. How do you determine the lateral and surface area of a figure? This is Unit 9, Day 6. We're going to start off with pyramids. Now notice what a pyramid is. The pyramid has one polygonal base, in this case it's a triangle, and then it has triangular faces, and they meet at a common vertex up here at the top. That's how you know that that's a pyramid. We name the pyramid by whatever the base is. So in this case, this is a triangular pyramid because the base is a triangle. A cone, it has a circular base, and the curved surface connects the base to the vertex. So notice we have a curved surface here, if you're picturing a cone, with a base of a circle. So notice here's just a comparison of what we talked about so far. We've got our two bases of a prism, two bases of a cylinder, but then a pyramid and a cone, we have one base each. All right, so identify the following. First of all, we need to talk about the shape. Well, notice if it's not circular and it meets at a point, it is a pyramid. Now we just have to determine that base. What polygon is that base? 1, 2, 3, 4, 5. So we know a 5-sided polygon is a pentagon. So it's a pentagonal pyramid. Our main vertex is this F, but we also have vertices of B, C, D, E, and A. Anytime we meet where the faces meet, okay, that's called vertices. Okay, so F is like our main vertex, and then any of those other ones are included also, but just keep in mind that F is the vertex of the pyramid, the entire pyramid. Our faces, well, we have faces here. Here's one right in front. So we name that. That would be triangle AFE. I'm going to go ahead and put a triangle in front of it because I know that it is a triangle. Then we've got another triangle, AFB. Then we've got another triangle back here, BFC. Notice, in the triangle, all of them have F as a vertex, if you notice. The edges, remember, are the edges that don't meet the base. Remember that from last time. So FA would be considered an edge. BF would be considered an edge. And then we've got all those other ones. Things to watch for. Altitude. We already talked about altitude last class, where we had, it forms a 90-degree angle. Notice this guy is slanted, so this is not called a right cylinder. Okay, this is not a right figure because it's not straight up and down. It's just like they took the bases and then they moved them apart. Kind of like, I always think of this kind of like a slinky. If you've ever seen what a slinky is, you can take it and separate the bases so they're not right on top of each other, and it makes it crooked. So what we do is we still take the very top of the figure and drop a perpendicular. In this case, the perpendicular is not inside of the figure, it's on the outside. But that's still considered our height. The other thing that's kind of new is slant height. Okay, the slant height is perpendicular to the edge. All right, so our slant height is this height right here. And you'll see it as a little cursive L most of the time. Will be a little cursive L. That's our slant height. Notice, if we knew the height and we knew the radius, we could always find the slant height by using Pythagorean theorem. Remember, a squared plus b squared plus c squared, where c in this case, our hypotenuse, is our slant height. We'll do some practice ones of those later on. So with our pyramid, our lateral area, okay, it's the same thing as what we talked about last class, where we take the perimeter of our base, times it by the slant height. The slant height, notice this is going up the side of the face. Okay, it forms a 90-degree angle with the edge of the base here. Okay, that's our slant height. And then we take half of it. So find the perimeter of the base. We have our slant height, which again, it's hard sometimes to put the right typing in there, but that is a little cursive L. All right, and it's half of the perimeter of the base times the slant height. So if we want to find the surface area of the whole figure, so make sure you write this down. Now make sure you write this down. We'll notice what 1/2 of PL is. Well, PL is our lateral area plus the area of the base. Now, with cylinders and prisms, we put a 2 in front of there because we have 2 bases. Notice this time we only have one big B because we only have one base. Cone, same idea. Again, this is our little L slant height there. And this time we want to find the perimeter of our base, which is a circle. Now, the only thing is here, you'll notice this is not what we had down, that's not the perimeter, but our perimeter of, our lateral area for a cone and a pyramid are the same. So it would be 1/2 the perimeter times the slant height. Well, we know that the perimeter of the circle is our circumference, so it would be 2 pi r times the slant height. Well, what happens with the 1/2 and the 2? They cancel out. So that's where we came up with the lateral area is equal to pi r slant height L. Okay, pi r L, because the 1/2 and the 2 canceled each other out. So I'm going to write it down here again. Pi r L. That's our slant height of a cone. Or I'm sorry, that's our lateral area of a cone. Okay. Now, in order to find the surface area, remember we have to find our lateral area again, plus the area of the base, which is a circle, and there we have the area formula for a circle, pi r squared. So make sure that you write these down and get these memorized. Lateral area is pi r L, surface area is pi r L plus pi r squared. And then finally, we have a sphere. Sphere is really easy to remember. All you have to do is take the radius, square it, times it by 4 and pi. So our surface area of a sphere is 4 times pi times the radius squared. All right, let's do some examples. Let's start off with our lateral area of a pyramid. Notice it's a rectangle as the base, so it's a rectangular pyramid. Our lateral area is 1/2 the perimeter times the slant height. Okay, so first off, the perimeter, if this is 6, this is 6. This is 3, this is 3. So we've got 6 plus 6 plus 3 plus 3. So we've got 1/2. Our perimeter is 18. Now, we don't have our slant height. So what we need to do to find our slant height is I know that the slant height is right here. It's going down this side, okay? And notice it makes a right triangle with the height, and then half of the base of the base, basically. Okay, so that would be 3. So we've got 3, 4. Now, if you remember from first semester when we were talking about right triangles, that a right triangle, a 3, 4, 5, that would be 5, makes a right triangle. But if you don't remember, we do 3 squared plus 4 squared equals c squared, or L squared in this case. 9 plus 16, 25 equals c squared. Square root of both sides, so c equals 5. So that means our slant height is 5. So we plug 5 in for our slant height. 1/2 of 18 is 9. 9 times 5 is 45. So it'd be 45 meters squared would be our lateral area. Now, we also have to add for our surface area. Remember, it's 1/2 PL, so our lateral area plus the big B, which is our area of our base. We already know what this first part is. Now we got to find the area of the base. Well, the base is a rectangle. We know that would be 6 times 3. So our surface area is 45 plus, multiply those together, 18. And then just go ahead and add them up. So 63 meters squared is our surface area. So you've got 1/2 of the perimeter times the slant height plus the area of the base. So our lateral area plus the area of the base. Okay, let's find the lateral and surface area of the cone. Again, we're going to have to find the slant height. Well, we can do that by doing Pythagorean theorem, so I'm going to go ahead and do that first this time. A squared plus B squared equals C squared, where C is our hypotenuse, that's what we're looking for. So it'd be 15 squared plus 8 squared. All right, 15 squared, if you remember, is 225. Plus 8 squared is 64. So that would be 289. Square both sides. Remember, opposite of square, and take the square root of both sides. So the square root of 289 is 17. So that means our slant height is 17. Now we're ready to rock and roll on finding our lateral area. So our lateral area, remember it was 1/2 of the perimeter. Well, if the perimeter is 2 pi r, the 1/2 and the 2 cancel out. So really we have the perimeter, we have the pi times the radius times our slant height. So we've got pi, our radius is 8, times the slant height is 17. So 17 times 8 is 136. So our lateral area is 136. Don't forget the pi. That is if we want the exact answer, or remember, if we want to round it, we take 136 times 3.14, and that would be 427.04. Both of these units are inches, so that would be inches squared, inches squared. So either one of these answers would work for us for our lateral area. Now, surface area, we just take our pi RL and we add the area of the base. Well, our base is a circle. We know the area of the base is pi r squared. We've already got the pi RL. I'm just going to go ahead and leave it in pi for right now. Plus pi times 8 squared. So our surface area is 136 pi plus 64 pi, because 8 squared is 64. Add them up. 200 pi is our surface area, inches squared, or 200 times 3.14 is 628 inches squared. No rounding on that because of 200 times 3.14 comes out to a nice non-decimal number. Again, memorize these formulas. It's going to help you out. Okay, now our sphere. Find the surface area of the sphere. The surface area is 4 pi r squared. So our surface area is 4 pi. Now you got to figure out what the radius is. That's the only thing we need to know. Well, this whole line is going across, so that means the diameter is 50. So our radius is 25, half of that. Make sure order of operations tells us to do the exponent first. So 25 times 25 is 625. Then we're going to multiply by that 4. And we get 2,500 pi centimeters squared. Again, you can plug that in the calculator. 2,500 times 3.14 is 7,850 centimeters squared. Now notice we didn't find the lateral area of a surface or of a sphere. Can you think of why? That may be a question that I ask in class. So be thinking of why we didn't find the lateral area of a sphere. Okay, our last example. Now, what if I want to find the surface area of this composite figure? What am I going to do? Well, do you see that we have two figures here? We have a rectangular pyramid and a rectangular prism. So what I want to do, and this is like if I'm wrapping this present. Maybe this is two separate presents, but I want to wrap them together. Okay? Am I going to wrap this part in here? Am I going to wrap that? Well, let's think about that. We'll come back to that in a second. But what I want to do is I want to take, because it's composite, so I'm going to take two different formulas, so one at a time. So I'm going to start with my rectangular prism. I'm going to label it really good so that way I don't get confused. And then I've got my rectangular pyramid. Okay, so if you remember from last time, our surface area of a rectangular prism is the perimeter of the base times the height. The perimeter of the base times the height. Plus 2 times the area of the base. For our rectangular pyramid, our surface area is 1/2 the perimeter of the base times the slant height plus 1 base, because there's only one base there. So let's take them separately. There's a couple different routes you can go, but this is the route we're going to take. We're going to take them separately. So our rectangular prism, so we're going to pretend like that pyramid's not even there. Well, if you notice, this even looks like this may be even a better one for us because we have 4, 4, so really this isn't just a rectangle, it's more specifically a square. So we know the perimeter of the square would be 4 times whatever this is, which is 4 in this case, so that would be 16. Times the height of the whole figure is 2. Plus 2 times the area of the base. Well, our base of a square is same thing, base times height, so 4 times 4 is 16. Okay, so our surface area, 16 times 2 is 32, plus 32. So our surface area of our rectangular prism is 64 meters squared. All right, halfway done. So now let's figure out our rectangular pyramid. Okay, so our surface area is 1/2. The perimeter of our pyramid, well, notice it's the same as the perimeter of our square, which is 16. Notice our slant height is going down the side face there. That is 4. Plus the area of the base is the same as what we had here. 4 times 4, 16. So I'm going to take half of 16 as 8. 8 times 4 is 32, plus 16. So the surface area would be 48 meters squared of our rectangular pyramid. Great. What do we do with the 2 to combine them? Well, we're going to add them together. That would be 112 meters squared. Is that our answer? Is that if those two things are put together, let's say we glued them together, would we need to cover those? No. The answer is no, we would not. So what do we need to take out from what we found? Well, we need to take out the base of the pyramid and the top base of the rectangular prism. So we're basically taking out 2 bases. Well, in our case, it was 4 times 4 was our base, which was 16. We need 2 of those taken out. So we're going to subtract out 32. That represents 2 bases not needing covered. Okay? 2 bases not needing covered. So when we subtract that, we actually have a surface area of 80 meters squared, or 80 square meters. That's our total answer. Again, I always think of if I'm wrapping these presents, I don't want to waste wrapping paper, so I'm going to stick them together, and then I'm going to try to wrap that whole thing. That'd be fun to wrap. But the point is that I don't need to cover those 2 bases, the base of the pyramid and the top base of the rectangular prism. All right, guys, that's all for today's surface area. That concludes all of our surface area. We'll do a little bit more, but these are the new figures that you need to know. So you need to know prisms, cylinders, pyramids, cones, and spheres. Those are the formulas that you're going to need to know for surface area. Again, make a summary of what you learned today, and create a question, either if you have a question of something that we've done, one of our examples, you don't understand something in the notes, or make up your own question that we could maybe show in class.